In earlier classes, we have learned the division of polynomials. As we have studied that a polynomial q of x is said to be divided a polynomial p of x completely if the remainder is 0. If q of x divides p of x, we say that p of x is divisible by q of x, or q of x is a factor of p of x. In this section, we shall study a theorem which will enable us to determine whether a polynomial q of x is a factor of polynomial p of x or not without performing the actual division. This theorem is known as the factor theorem and is shown as here. Theorem: let p of x be a polynomial of degree greater than or equal to 1 and a be a real number such that p of a is equal to 0, then x minus a is a factor of p of x. Or conversely, if x minus a is a factor of p of x, then p of a is equal to 0. Proof: first, let p of x be a polynomial of degree greater or equal to 1 and a be a real number such that p of a is equal to 0, then we have to show that x minus a is a factor of p of x. Let q of x be the quotient when p of x is divided by x minus a. By remainder theorem, we already know that p of x when divided by x minus a gives a remainder equal to p of a. That therefore, p of x is equal to x minus a into q of x plus p of a. That is, p of x is equal to x minus a into q of x, where p of a is 0. Therefore, x minus a is a factor of p of x. Conversely, let x minus a be a factor of p of x, then we have to prove that p of a is equal to 0. Now, x minus a is a factor of p of x. We already proved that. P of x when divided by x minus a gives a remainder 0. But by remainder theorem, p of x when divided by x minus a gives a remainder equal to p of a. Therefore, p of a is equal to 0. In the factor theorem, we have 4 possibilities and let us look at them now. Now let us see the 4 possibilities. If x plus a is a factor of a polynomial p of x, if p of minus a is equal to 0, ax minus b is a factor of polynomial, then p of x if p is b by a is equal to 0, and ax plus b is a factor of the polynomial p of x if p is p of minus b by a is 0, and x minus a into x minus b is a factor of polynomial p of x if p of a is equal to 0 and p of b is equal to 0. Now let us solve some interesting examples. Now let us see some examples. Using factor theorem, find whether the polynomial g of x is a factor of polynomial f of x or not. Given f of x is equal to x cube minus 6x square plus 11x minus 6 and g of x is x minus 3. Let f of x is equal to x cube minus 6x square plus 11x minus 6 be the given polynomial. By factor theorem, x minus a is a factor of the polynomial f of x if f of a is equal to 0. In order to prove that x minus 3 is a factor of f of x, it is sufficient to show that f of 3 is equal to 0. Hence, f of 3 is equal to 3 cube minus 6 into 3 whole square plus 11 into 3 minus 6, which is 60 minus 6, 60 minus 60, which is 0. Hence, it is a factor. Let us see another example. Given f of x is equal to 3x cube plus 3x square minus 20x plus 12 and g of x is 3x minus 2. Let f of x be 3x cube plus x square minus 20x plus 2 be the given polynomial. Again, by factor theorem, if x minus a is a factor of the polynomial f of x if f of a is equal to 0. In order to prove that 3x minus 2 is a factor of f of x, it is sufficient to show that f of 2 by 3 is equal to 0. Hence, substituting f of 2 by 3 in the above expression, we have 3 into 2 by 3 whole cube plus 2 by 3 whole square minus 20 into 2 by 3 plus 12, that is 24 by 27 plus 4 by 9 minus 40 by 3 plus 12, 27 as the LCM, you get 360 minus 360 by 27, which is 0. Hence, it is proved. For what value of a is x minus a is a factor of x cube minus 3x square plus ax minus 10. Let f of x be x cube minus 3x square plus ax minus 10 be the given polynomial. In order to prove that x minus 5 is a factor of p of x, it is sufficient to show that p of 5 is equal to 0. Therefore, P of phi is equal to f of P of x is equal P of phi is equal to f of x is equal to 0. Therefore, substituting the value of phi, you get phi cube minus 3 into phi whole square plus a into phi minus 10 is equal to 0. That is 125 minus 75 plus 5a minus 10 is equal to 0. 40 plus 5a is equal to 0. 5a is equal to minus 40, or a is equal to minus 40 by 5, which is equal to minus 8. Hence, the value of a is minus 8. Example 3, if x cube plus ax square minus bx plus 10 is divisible by x square minus 3x plus 2, find the value of a and b. Let f of x be x cube plus ax square minus bx plus 10 and g of x be x square minus 3x plus 2. We have g of x is equal to x square minus 3x plus 2, that is on factorization we get x minus 1 and x minus 2. Clearly x minus 1 and x minus 2 are the factors of g of x. In order to prove that f of x is divisible, exactly divisible by g of x, it is sufficient to show that f of x is exactly divisible by x minus 1 and x minus 2. For this, we shall show that x minus 1 and x minus 2 are the factors of f of x. Therefore, we have substituting f of 1, we have 1 cube plus a into 1 square minus b into 1 plus 10 is equal to 0, or a minus b plus 11 is equal to 0, or a minus b is equal to minus 1. This is expression number 1. Now let us take the value of f of 2, which is 2 cube plus s a into 2 square minus b into 2 plus 10, a plus 8 plus 4a minus 2b plus 10 is equal to 0, 4a minus 2b is equal to minus 18, or it is divisible by 2, 2a minus b is equal to minus 9, expression 2. Solving 1 and 2, we have a is equal to 2 and b is equal to 13.